Welcome everyone to the final episode of our base building tutorial series. Indeed, the final episode because I've decided not to implement the need system in this game. I'll get into the reasons for that a bit more later on in the video, but the primary reason is I do not feel that the system as I had it prepared is robust enough to use as a showcase. What I do want to do is today improve the entity AI a bit, in particular a specific case, and then let's focus on wrapping this one up. So let's open our base builder tutorial, and I'm first going to show what I want to fix for today. So let's run our game. Zoom in a bit. So let's say we have a kitchen counter. Wait a sec. I guess we're missing our entity in our world. Sorry. So let's re-enter that one first. So let's zoom in. We have our entity. Let's install a kitchen counter and let's see what happens. So the kitchen counter gets installed and the entity starts converting food into cooked meals. This is what we saw earlier already. Now, at some point in time, there's no more food left to cook. Now, when I want to schedule a job like this one, changing this wall to a floor, it never gets picked up because the entity is sort of soft locked because it only still has the job to try and cook food, and because it still has a job it tries to perform, it never picks up the other one. So this is clearly unintentional behavior. So let's work on fixing that today. Let's close this one. Let's get back. So what we're seeing happening is that currently the entity just tries again and again to perform a job, even if it's never able to do so. What we want to do is we want to re-enqueue a job into the world's job queue if it's a job that we can't resolve by simply creating some other job. So for instance, if the entity is not at the correct location to perform a job, then that can get resolved by first performing a move to job. This isn't the case if there's not enough items of a specific type in the world. So that's a different case, and in the last and latter case, we want to re-enqueue those jobs into the world's job queue. This way, the entity's job stack is empty to pick up some other job, and the other job can be picked up at some later time. And to do this, we need to differentiate in the ways requirements can be met. Currently, we just return a Boolean value to check if a requirement can be met, but we want to be a bit more explicit that the requirement is met, and then we can just continue, for instance, to the next requirement to check. It can be unmet, but then we can try and schedule a different job to meet the requirement, for instance, a movement job. And it can be impossible to meet in the current world state, for instance, because a specific object is not available anywhere in the world. In this case, we want to re-enqueue the job in the world. So let's get started. So let's start by writing a test in our entity tests, and let's create a new one here. We will call it test job with requirements that cannot be currently met in the world is re-enqueued in the world. So we need a world. And we need an entity. At some position. We also need an item to fetch, something that is required to perform a specific job. Let's say an item to fetch. And we need to have a job on the in the entities job stack. So one on the bottom, this will be something to, for instance, change a tile. And this can be a job to change the tile to a wall. We'll have a target position where we already are. We'll have a build time 1, and it won't have any requirements. Then we have a top job, and this will be a job that we can't perform. This one will be also a change style job. Stone 2 will have a target position and a build time of 1. This one will have requirements, and this one will have an items requirement for an item stack that contains the item to fetch, and we require, let's say, 2. So let's get them on the entities jobs stack. So first we push the bottom job, and then we push the top job. Okay, so let's assert some stuff. So let's assert that the entity now currently has 2 jobs in the queue. And also assert that the world has 0 jobs in the queue. Then assert that our entity jobs.peak, so the top job description is indeed the top job description. And then let's update the entity in the world. And let's assert again. So now we should see that if the job gets re-enqueued in the world, that the entities jobs queue has only 1 job, and the world has 1 as well, because that's where the job gets enqueued. Also, the description should be that we now see the bottom job description, and in the world we see the top job description, because that's the one that gets re-enqueued. So let's run the test. Let's see. Oh, the world has a jobs queue, and the queue does not have a peak method. So let's find the one in the stack, and let's add something similar to our queue. So we can queue look at the first job that's in the queue. So let's go back to our tests and see if they now run and compile correctly. Also, I'm going to make this a bit more explicit that these have different types, because I also want these ones to fail. They now succeed because they have the same description, because both try and change into a wall. So let's see if we now get a bit more specific. These ones also fail right now. So that's good with our red state. So let's start working on our entity. So let's see. So let's go to our entity, and what we need to do is we have a check requirements function here that returns a Boolean. And what we want to do is change this into some form of result that can differentiate between the various types of result we understood. So let's see. So we have our entity. Let's create a new enum called check requirements result. And this one can be met, can be unmet, and can be impossible to meet in current world state. So we're going to use this one instead of just a Boolean value. So now if we go into our check requirements function, this one currently just checks for the for a Boolean value. We're going to change this one around. We're going to use a switch statement, and we're going to switch on the check requirements. So we're going to take this one, and we're going to switch on this one, and get rid of this. And let's see. So we will have a case that this one is met. Then we can just break from our switch. Then we can see it's unmet. In this case, we say logger the debug did not meet requirements for current job. Something like this. And then we return. And then if it's impossible to meet, then we take the job from our stack and we go into our world, add enqueue our current job. And then we return. And only in the case of the first one, the break, we don't return and continue with the actual building process. So the next step will be to go into our check requirements function. And this one currently returns a Boolean. This should return a check requirements result. So the first thing we do is, well, this to do has been done. So this one we can get array of anyway. So we have our we should first try and get a fetch job. So let's see. So we have our try spawn fetch job function. Let's make sure this returns the actual job that we want to use. So this returns an optional job. And let's see. So let's make it like that. If we have a fetch location, and that will be this one, else we should return nil. Otherwise, we can just return the job. Now, let's see. So we have our items requirement. If we are able to get this fetch job, if we can't get any fetch job, then we return that it's impossible to meet in the current world state. Otherwise, we will push the new fetch job onto the stack and debug this message. Okay. So the second one is a position requirement. This one always, it's always possible to create a position or move to jobs. So here we can just say we met. It's unmet. Also here we should say that we return unmet. And the final one, this one should also say that it's unmet. And if we reach the end here, then we can say the requirements were met. So if we didn't make any big mistakes, this one should compile. And the test should now pass. Look, indeed, the tests passed. We can also build and run the game. Let's zoom in a bit. Let's build the kitchen counter. Let's have it cook some food. Okay, so there's no more food to cook. So now it's sort of stuck, but now if we say we want to change this one to a flooring tile, it will indeed start also building these kinds of things. So we can schedule new jobs and those will be picked up. So that's that. So that's a small improvement to the entities AIs, but it will make a big difference in how playable the game is. Let's get back. So we were able to prevent this soft lock. Now let's wrap up the series and first have a look at everything we did. So we integrated SpriteKit and SwiftUI, which works quite well. We created a fairly robust job system that can be extended even quite a bit with different job types. But even with these small numbers of jobs type, by adding more items and objects and tile types, I think you can create a pretty sophisticated game if you want. We wrote a lot of tests to validate functionality, and we created a world that can be changed. So we can change tiles, we can install objects, and we had items, inventories, and recipes. So that's quite a bit. What we didn't do is implement the need system, and the main reason is the system I had sort of prepared is that wasn't really robust and was such bare bones, and in the end also only just adding additional jobs that I don't think had any value, a real value to show. I think there are more interesting ways to implement like a need system or an AI system that tries and determine between various possible actions. And it's also something I want to look into in the future. So this is probably something we will revisit, but then in a more sophisticated and more robust way. Something a bit more like the job system in that sense. We also didn't implement pathfinding for entities. Main reason is we already covered pathfinding in the previous game. It will probably mostly make the game slower because then entities also had to walk around, and I wanted to focus in this case on the job system. And finally, we didn't really use any of the visual stuff SpriteKit is able to do. Not in this game and not even in the last one. So we didn't do animations, actions, or particles. Basically, we're just using SpriteKit as a DOM visualization layer that just shows a sprite in a specific place. And that is what I want to focus on in the next game. So really have SpriteKit flex its muscles a bit more, play animations, change animations based on world state, use actions to move stuff around, perhaps do some particles. Basically, using SpriteKit more or less the way that it was intended. So if you hung around till the end, thanks for watching, and until next time, have a good day.